All right, let's talk about one of the most powerful and, let's be honest, sometimes confusing features in C#, async and await. We're going to break down asynchronous programming and make it super simple and practical. So let's start with something I'm pretty sure we've all run into. You click a button in your app, maybe to download a file or fetch some data, and then, bam, everything just locks up. The screen goes white, you get that spinning wheel of death, and you just know your users are getting frustrated. Sound familiar? Yeah, I thought so.
Okay, so let's dive right into why that happens, that freeze. It isn't really a bug in the way we usually think of them. It's actually a design problem. It's what happens when your application's main thread, the one that's supposed to be handling all the clicks and keeping the UI looking fresh, is told to just wait.
This slide, right here, shows the two different worlds we can live in. On the left, you've got that frozen UI. The main thread is basically being held hostage by some long-running task. The user can't do anything. But over on the right, that's where we want to be, a responsive UI. The main thread is free, so the user can keep on clicking and scrolling. And the secret to getting there? Waiting asynchronously.
So how do we actually get to that awesome responsive world? Well, C# gives us a really simple promise, and it's built on 3 key ideas that all work together. Let's break them down one by one.
First up, we have the task. Now, I want you to think of a task like getting a ticket at a deli. You don't just stand there at the counter staring at the guy making your sandwich, blocking the entire line, right? No. You take your ticket, that's your promise that you'll get your food later, and you can go check your phone or whatever. In our code, the task is that ticket. Next is the async keyword. This is kind of like putting a little sign on your method that says, hey, just a heads up, this function might need to wait for something. But don't worry, it knows how to pause politely and let other stuff happen. It's basically the permission slip that allows for all this non-blocking magic.
And this is where it all comes together, await. This is the actual instruction. When your code hits an await, it's saying, okay, right here, I'm going to pause this method's progress. Give control back to whatever called me, and I'll come right back to this exact spot as soon as that ticket, that task, is done.
This coffee shop analogy is just perfect. A normal, synchronous call is like standing right at the counter, blocking everyone behind you, just waiting. But using await, that's like getting one of those little buzzers. You're totally free to do other things, and when that buzzer goes off, when the task is complete, you just go back and pick things up where you left off. The whole system just keeps on moving.
Okay, let's see what this actually looks like in code, because the difference on the screen might look small, but the impact it has on your app is absolutely massive.
Just look at this side by side. On the left, Thread.Sleep literally puts the entire thread to sleep. It's doing absolutely nothing. It's just wasted time. And if that were your UI thread, your app would be frozen solid. But on the right, Await Task.Delay does something incredible. It says to the system, hey, I need a 3-second pause here. And then it releases the thread to go do other useful work. Once the time's up, a thread comes back to finish the job.
So, this is it. This is the big one. If you only remember one thing from all of this, make it this. Await pauses the method, not the thread. The thread goes back into the pool, totally free to update your UI or handle another web request. That is the entire secret.
This also opens up some amazing performance gains. On the left, we're waiting for 3 tasks, one after the other. If each one takes a second, our total time is 3 seconds. Simple enough. But look at the right. We start all 3 tasks at once, collecting their tickets, their task objects, and then we just wait for all of them with task.winAll. They're all running at the same time. Now the total time is just 1 second. That's a huge win, especially when you're doing things like calling multiple APIs.
Now it's really important to get this next part. Async and await are the perfect tool for a specific kind of problem, but they're not a silver bullet for everything. You've got to know when to use them.
And the key difference is this. Async/await is for I/O-bound work. What does that mean? It means your code is spending most of its time waiting. Waiting for a network, a database, a file on the disk. Now, if your code is doing some heavy computing, well, that's a different problem, and it needs a different tool.
This table lays it all out. If your problem is waiting for I/O, async and await is your answer. It handles that waiting time super efficiently without hogging threads. But if your problem is CPU-bound, complex math, processing tons of data in memory, then you want to use something like task.run to kick that hard work over to a background thread, so it doesn't freeze up your UI.
Now, like any powerful tool, there are a few common traps that are super easy to fall into. But hey, knowing what they are is half the battle. So let's walk through the big ones.
Okay, first, and this is the most important one, avoid calling .result or .wait on a task. It's a classic mistake. It blocks the thread and is a recipe for deadlocks. Second, try really hard to avoid async void unless you're in an event handler. Async task is just so much safer. And finally, a little pro tip for you, especially if you're writing libraries. Use configure async false. It just helps prevent deadlocks in more complex apps.
Let's really hammer this one home. The second you type .result on a task, you are blocking, synchronously. You're telling your thread, stop everything you're doing and just wait right here. This is the anti-pattern. This brings back the frozen app, the whole problem we were trying to fix in the first place. Just use await instead.
All right, we've covered a ton of ground here. The theory, the code, the things to avoid. So to wrap it all up and make it really concrete, here's a simple checklist you can use when you're writing your own code.
It really is this simple. Waiting for I/O, async and await. Got a bunch of independent requests to make? Kick them all off and then use task.winAll. Got a huge heavy calculation? Offload it with task.run. And if you're building a UI app, the golden rule is to keep that UI thread free. Use async all the way from the top to the bottom.
So that's really the heart of Async Await. It's not about making your code run faster, not really. It's about making your application way more responsive and scalable by not wasting precious threads on just waiting. It turns that waiting time into productive time. Which leads me to one last question for you. Think about your own code right now. What's the first blocking call that you're going to go and change?